Thank you so much for this opportunity. Just to kick off, my name is Makgato. I'll be talking to you about the graphs and functions. That is grade 12 paper 1 algebra. And I think for me, I'll just be looking at the pros and cons in terms of what is it that you need to know, so that you can be able to tackle any graphs and functions problems that is given to you. I think the way I've structured this lecture is just starting with a recap in terms of saying what is it that you need to be knowing to be able to solve this, in terms of saying for any specific graph and function problems, what is the typical equations looking like, what does it tells us, and then how do we read um, the coordinates. All right. So in terms of the introduction and the recap, so what are these functions basically? So in terms of the general definitions, we have got the different types of basically functions. So it's either we're talking about the linear functions. So those linear functions, they are defined by equations y equals to ax plus q, which is generally known as y equals to mx plus c, where your a in this case is your gradient of that particular linear functions. There are also quadratic functions, which is defined by actually y equals to ax squared plus bx plus c, or it can also be defined by y equals to a into x plus p squared plus q, where your q in this case is your y-intercept. There are also hyperbola equations. These are equations basically defined by y equals to a over x plus p brackets plus q, where basically this is your y-intercept in this case is actually your q, and your gradient in this case is the number before a over x plus p, that if you're to solve for any x variable in this case, you'll just let your y-intercept to be equal to 0. And then obviously there are also what you call the exponential functions or graphs. Those are defined by y equals to ab to the power x plus p. So when we're talking about exponential functions, in exponents, you will always have a base and an exponent. So when the exponents will definitely be telling you how many times you got to multiply your base. So in this case, when you go to y equals to ab to the exponents, that basically define your intercept, and of course your y-intercept will be defined in this case by q. And of course there are also inverse functions of either any of these. We can also be looking at the inverse functions of any of this, where it is 1 over that particular equations. What we need to take from this is, in terms of the linear graph, how does they look like? Normally these are just straight line functions, and then of course the parabolic graphs will normally be this curved. This is what a parabola will be looking like, either facing up or down depending on the intercept or actually the gradient. And these are parabolic functions, hyperbolas, and obviously this one are the exponential functions. What is important in terms of this, what you need to know as a student, I think you need to be able to read, to visualize what a typical equations of a linear function looks like. And of course, with that, visualizing that in terms of saying how does the shape look like. The quadratic functions, they've got various equations depending on how it looks, and basically this and how the function or the shape. So quadratic equation can take any form of this. This is the equation, depending on your y intercept, and obviously from this, then this will be the typical shape. And looking at the hyperbolic functions, this is the typical equations. These two equations that normally accompany the hyperbolic functions, and this will be the typical shape of this. The exponential functions will be this is the typical equation defining how an exponential function should be, and of course this will be the typical shape of this. Now, what is important to know? Why is it important to know these equations? This is very important because when you are going to be plotting these graphs, you need to know what does each variable actually mean, and how do you then define what the turning points of that particular function is, because that you need to be able to read from any quadratic equation. So this quadratic equation, for example, if you look at this, taking this as an example, f of x is equals to ax squared plus bx plus c. So this is a typical quadratic equation. So what it means is that at any given point, if you want to find the c, in this case is your y-intercept, and if you are to define any of your x-intercept, then you'll have to let your y be 0 and then solve these quadratic equations. Similarly, this can be done for any of these functions, and we need to be able to know what each variable in terms of the y-intercept and the x-intercept mean. Don't stress a lot at this point in time. I think it might look a little bit difficult, but as we'll be doing examples of this kind of functions, then it will become more clearer and clearer in terms of what to look for and what we need to be chasing. Yeah. So a typical quadratic function, for example, we've already defined the standard form of an equation that defines a quadratic function. But as we've already defined those standard equations, what is of paramount importance is the fact that you got to know the turning point. So from that quadratic equations, you need to know the turning point. So when that function turns, it has to have your x. Your turning points got two points. It is the x intercept, or what we call the x coordinates, and the y-intercept, which is also called the y-coordinate. So at any given point where your function 10, it must have the x-coordinates and the y-coordinates. Normally it's x, y. So for the equations that we've defined, so what is important to take from those equations is, from that equations, how do you then read the turning points of a function? So these are already derived turning points equations from all the standard equations that we've been given, and this is how we're going to be able to find the y coordinates. For example, if you take a standard equations of y equals to ax squared plus bx plus c, and then the turning points of that particular function for the x coordinates, or the x-axis, or the x intercept, could be defined as x equals to the minus b over 2a. So the b here in this case, so we'll be able to read it from this graph, from this equation, and over the a is actually, you should also be able to read it there. So that means, for example, if your b is 4 and then your a is 2, then that will be 4 over 2 times 2, that is 4 over 4, which is 1. So that it means that your x turning points, or the x coordinates for that particular turning point, will be minus 1. So, but we'll have to then look at how do you get the y-intercept for that particular x coordinate. So we got to substitute the x value into the original equation to determine the y value. So because on any function, what happens is that for you to be able to determine the y intercept of this quadratic equation, so you must let the x be 0. So then when your x is 0, then that means then your y will be equal to c. And then similarly, if you have to find the x intercept, you will go to let your y be 0. And then when your y is 0, then you are able to solve that particular quadratic equation so that you can be able to find the y-intercept. So once you've got ax squared plus bx plus c, that is a quadratic equation. So what it means basically that the values of your x intercept then will be 2. So there will be 2 values because this is the quadratic equation. You should be able to solve. When you solve this, means you're going to find 2 values. So this 2 for quadratic equation, it basically means that you got 2 values for your x-intercept, which you should be able to find in this case. So similarly for this equation, if your equation appears in this format, then you'll be able to say this your x turning point of that particular equation, it will be your minus p, where you are able to read your p there, and then your y in this case it will be read as q. So similarly, if you look at another equation, this one, your x turning points, it will be x1, x2. So basically these are the factors of that particular quadratic equation. So because we look at the x1 and x2 over 2, so that it means that the 2 factors of that quadratic equation, so over 2, so that will give you the x-intercept or the x turning points. And then of course, for you to determine your y in this instance, then you have to substitute your x values basically on that equation. Then once the x is substituted, then you will be able to find how much your y will be. Lastly, on these quadratic equations, where we say what does the turning points mean, so we can be able to look at this one and say, now how do we determine the turning points? So the x will be equals to the function of x, where f actually function of x is equal to 0. So what it basically means is that you have to solve these quadratic equations in the sense that so that you can be able to find the values of this, where f of x, it basically means that you need to equate this equation to 0 and then solve this to find the values of x that will then be the turning points. And having got that, normally you'll substitute then your x here to find your y. So once you substitute the value of x into the original equation, then you can be able to determine the y. But in this instance, of course, your values of y should definitely be closer to c. Maybe let's look at a typical example. So how do you then sketch a graph when you are given a function? I think the first point is to determine the shape of a. So the shape of a basically a function where you said your a is greater than 0, or either when your a is less than 0. So it's either is facing up or is facing down, depending on the value of a. That a, you get it from the quadratic equation. So it's either when your a is greater than 0, that means your a is positive. So, and when your a is less than 0, that is when it is basically negative. Your equation can be starting as negative 2x squared. So from that, you will be able to know whether it's facing up or it's facing down. So when it is positive, in most cases, um, so it will be sort of phasing up, and and then when it is actually negative, then it will be sort of phasing down. So from having defined the shape of whether it's going this way or this way, um, then you will be able to find your x-intercept by letting your y be 0, and likewise, when you find the y, you let x be 0, and then you find the turning points. We've already defined how you find the turning points based on the equations, and then you can be able to plot and the points. The plotting the points says where does your x-intercept stand, sit. You can have two x-intercept and y-intercept, and then, for example, if something is touching at -2 and +2 on the y-axis and on the x-axis, and of course 1 at the y-intercept, then it can actually be coming that way and that way. So that is a typical example. Of course, we'll start with simple examples, and of course, in maths, normally you start with simple problems, and as you build up confidence in terms of how to address that, then of course it will get a little bit complex in terms of dealing with multiple functions at the same time. Let's say, for example, let's have a look at this example. Of course, this is fairly simple, but in terms of trying to see how to apply the knowledge that we've just been building in, it should be relevant. So let's say, for example, we are given f of x equals 2x squared minus 2. It is very simple, but in terms of saying how do you tackle this? Because the first point of departure will be to say which equations, which of the quadratic equations satisfy this. What are we talking about? So when we're talking about those quadratic equations, we're saying you've got these equations, and now when you've got those equations, which of these actually define that? So you can look at this. This is 2x squared minus 2. So when you say 2x squared plus, when your b is 0, then yeah. So when your b is 0, then that automatically will cancel, and then when your c becomes -2, then that definitely will qualify to say y equals to 2x squared minus 2. So while we're still here, so because the first thing is to determine the equations. So then you can be able to say now, what will be the turning point of that? So x will be equals to minus b. So when that automatically becomes 0, and then that will be 2 times that's 2 times 2, that is before, so that will be almost 0, and then your x-intercept in this case, substitute the x value into this, that becomes 0, then that will be equals to what? 2 minus 2. Then, so the first question will be to determine the coordinates of y. So determine the coordinates of y-intercept of the graph of f. So that means to determine the coordinates of y, you got to let x be 0. So once your x is 0, then that y is equals to minus 2. Determine the coordinates of x intercept. So for you to be able to determine the coordinates of x-intercept, you let your y be 0. So, or f of x, I think, sorry. Made a mistake, sorry. F of x is actually this one. Hence, f of x is equals to, then what we are going to do, so it's actually this one. I need to put in pointers. So that means that we are going to equate this to 0, and then 2x squared minus 2 is equals to 0. When then it's either we can say we cancel the 2 and have what we call, or we can take 2 out. 2 into x squared minus 1, and then the 2 divided by 0 becomes 0. Then we got x squared minus 1, which is the difference between two squares. So that will be x minus 1 into x plus 1. And then that will be x is equals to plus 1, or x is equals to minus 1. So your coordinates should be x equals to minus 1, x equals to plus 1. Yes. And then in terms of the turning points, sorry. So the turning points of this will be equals to x is equals to minus 1. This is equals to minus 1, and then minus 2. So that will be minus 2 for your y and 0. So in terms of the range, when they say the range is actually y equals to your range. Your range will be equals to your x-intercept, and then your y-intercept. So that is normally where you actually find the range. But then when you are introducing a, if you've got another coordinates or the points being given on a specific graph, so that graph now they're saying determine a if 2 and a is a point on the graph. So what does that mean? That means that now in that particular graph, you're going to have your x-intercept being equals to 2. Then if this is 2 squared, 2 multiplied 2 squared, that is 4 multiplied by 2, 8 minus 2, that will be equals to 6. That's what it means about your y-intercept of that a when your x is 2. So let's look at this example. So indeed, these are the possible solutions to say, in terms of your y-intercept, yes, we said the y equals to 2 and x will be equals to 0. And then we set how to solve this, the difference between 2 squared. We talk about 1 and minus 1, and 1 and 0 and that. So this is where it is actually in plotting, because passing here minus 1 and 1 and negative 2, that is where your x-intercept. So your range is normally equals to your negative of your y-intercept and up to infinity. So maybe not to change this to say take home. So we'll give students some time to say now, after having done this, then as a typical example, we'll have to look at what is it that they don't understand, or what has been difficult, or what was a misunderstanding. And then from there, then I'll give them this one. I say, can you please tackle this one? Now, this is a combined quadratic equation with a linear equation. So this one, the gx, this is a linear, and this is a quadratic equation. So if you were to divide by 2 here, This is the same as x squared minus 3x minus divided by 2, 1, 2, 3. This is a 3, and divided by 2 here is, you can actually get 10. So now when you're going to get the factors of this, 10, so which are the factors of 10 that can leave us 3? That will be what? 5, x minus 5, okay, and then x plus 2. Yes, then you got 5 multiplied by 2 is 10, and then you'll have x minus 5, and then x plus 2. So x equals to plus 2, and x equals to minus. Yeah, so the factors. So if we divide this one by 2, x squared minus 3x minus 10. So, but the factors will be x minus 5, x plus 2, and then when 5 subtract 2 will give you the 3. So then already we know what these values are. So x minus 5, x plus 2, x is equals to 5, x is equals to minus 2. So here is minus 2 and 0 here at A, and this is 5, and that is minus 2. Minus 2 and 0, 5 and 0. If you want to find the y-intercept of this, it will be this is x squared minus 3x minus 10. So that means your y-intercept on the quadratic this quadratic equation then will be minus 10 here, and then your linear, this one will be equals to x equals to minus 2x plus k, but your k in this instance it will be equals to your y-intercept. Y is the y-intercept. This is the point where your gx is cutting your x-intercept. So in terms of the coordinates of basically D, so this is a typical quadratic equation. So if you want to find the turning points, you first look at this function, and then you can say, okay, this function, you are going to have used that equation of your x-intercept equals to minus b over 2a minus b minus into minus b. This is minus b 2 into 2a. This is that one. And of course, you y-intercept, you let this be 0. And then you get your x-intercept. So the coordinates of a and b that we have, these are the factors that we solved. The value of this, for you to be able to solve k, yeah. So what you do is because the point where k and the f function and the g function meet, they are actually equal. So what you basically you can equate this and make x to be 0, and then be able to solve this. 87 minutes. Yeah, so you equate this, you solve them, you let x be 0, and then you find the value of k. The value of p, if this function has no real roots. So if they've got no real roots, then what it means is that then you're going to use the equations, using the equation of y equals to ax squared plus bx plus c. We know that your x will be equals to the solved quadratic equation, which is minus or plus or minus square root of b squared minus 4 minus 4ac over 2a. That equation, then you will actually use it, and then you get the value of p. So for which values of x is when this is actually, when you multiply the two equations, when it is actually less, you are looking at the bottom part. But of course, when it is greater than, it should be on the positive side. So this is, you are looking on this side. So I think I'll have to have markers so that I can be able to point. So the value of t, if this is a tangent, yeah. So what is a tangent? A tangent is normally a line that touches a parabolic function once. So when they touch, they are equal. If they are equal, then what you do is you equate the two, and you actually solve. When they touch, they are equal. You solve this one and this one, and then simultaneously, and then you find the value of t. So that is how we'll be able to look at it. Moving quickly to determining equations of a parabolic functions. These are the equations. Now, in this case, we are saying this, then you need to know what to define the turning points for the x and how to determine the turning points for the y-intercept for each and every given function. So from that, then we'll be able to look at a typical example of a parabolic function given that, and then that has been sketched below. These are the points. These are the points A, and then these are the points B. The B is another point in that particular parabolic function, but obviously it's touching the x-intercept on the negative side here at C. And then so one of the things that we'll have to do is to write down the coordinates of C. So the coordinates of C, you can see that these coordinates will be coming from here. So if you were to plot this, if this is your Q, and then this will be if you solve this, normally with the difference between two squares, you can get so A20 coordinates of A, then that will be the coordinates of C will be -2, 0. Determine the equation of F. The point A and the point B lies on the line on the graph of F, and now you might be able to calculate the point. So now if you have got these 2 points, so now once you've got C be -2 and 0, and the A be 2 and 0. So what are these are the factors? Then we know that these are different between two squares. So that way we've been x squared minus 4. So if you solve y equals to x squared minus 4, that will give you x minus 2, x plus 2. So that -4, then that is your y-intercept here. Okay. So the equation then f of x equals to x squared minus 4. Write down the range, -4, and then that will be the infinity. Write down the range of h, where this h of x is equals to the minus f of x minus 2. So now you've got that equation. You can substitute that equation of f of x, but you must add the -2 and add minus. So you multiply that equation f of x squared minus 4. You multiply by -2, and of course you subtract -2. Then that is how you simplify it. So we have said the difference between two squares, the C, that is -2, right? And then that will be another, so the -2 we said is this side. It's -2 and 0. And then the next one will determine the function of f So these were the given points. So what we need to do here, let me just see. So this is equation, yeah. So the equation that defined that is actually this first equation. So I think what I need to do is to, without going back and forth, I must bring the equation where it's actually said. So because your x1 and x2 are these are you directly substitute that, and then this we talk about the difference between two squares. When you substitute your b, this is your x. This is where that line there is. If you want to find your y, you substitute for your b, and this is your x and your y. Where is that point? That is that point there. So if you substitute at any given point, then you're going to find what your y is. And that y will be minus 2. And then minus 2 up to infinity, that define that. And then what is your f? Sorry, your last question was the coordinate? No. Not this one. If the coordinates of r is this, use the graph to determine the value of x for which the function of f is less than the function of g. So this is f on top of g. Where is the f? The f is this one, and this one when this one is in top. So what will be the value of x? Sorry. This is this one. And then how to do the, so we'll substitute this one and we'll find your y intercept. So already we know what the x-intercept, the x-intercept were actually this difference between two squares. And then from that we'll check if there's any questions for clarity, and we'll do that, and we'll give them the similar one to solve. And after that, then we'll have a take-home assessment, and we'll tell them that the next assessment will be hyperbolic functions.